Welcome to Module 11, which is Lesson 1, Defining Climate. All right, so the focus question today, what is the difference between climate and weather? So we learned that a little while ago, but climate is long-term, so 30 years of data, whereas weather is like what's happening today or tomorrow. All right, so jet stream. So it is a review, but jet stream is that high band of wind that moves in between in the westerlies. And so basically, it's separating the polar air from the tropical air. And so here we've got this low pressure system and high pressure system. And where those two systems meet is where we get our most severe weather. So here is the Midwest where we get most of our tornadoes at. And that's why, is because the jet stream influences that. And then also brings cold air. So this would be, since the jet stream is coming from the north, it'd be bringing cold air. And then here it's coming from the south. So it'd be bringing this warm air, high pressure. So that's jet stream. All right, so climatology is the study of climate. So we study past records, we study present, we study maybe future climatic changes, like global warming, for example. But climate is just the long-term weather. So what is the long-term weather, 30-year plus span in that area? And we look at the data from, like I said, 30 years or more of data in order to determine what the typical climate would be. So for us, we have hot, dry summers, mild, wet winters. And so that would be our climate. And obviously that can change and vary a little bit. And then we get droughts or overly wet periods. But generally, that's our climate. All right, so we look at the climate data in order to find what we call normals. So normals are just a standard value. So for example, we might have 30 inches of rain per year. So that would be our normal. And if we have more than that, then it's a surplus year. And if we have less than that, then maybe it's a drought year. So that would be just our normal. So they set these normals like temperature wise too. So in the summertime, normally our temperatures are 90 degrees plus. If we have a cold spell, like a cold wave, for example, we might get temperatures in the 70s for a week or so. And so that would be not normal. And then other things that factor into climate and changes in normals would be elevation. If you're close to a large body of water, so for example, Eureka is the same latitude as us, so they should have the same weather. But there's mountains that surround us. There are mountains that generally don't surround Eureka. Eureka is on the ocean, whereas Redding is not on the ocean. So that definitely causes climates to vary. All right, so latitude is one thing that affects climate. So latitude, if we look at this picture on the left, the sun's rays are hitting the near the equator more directly, so they're getting more intense radiation. And then as you go farther away from the equator, you get more angle, and so you get less direct sunlight. So that's why the poles are colder than the equator. And so this would be, in this case, winter because for us. So the northern hemisphere, this part right here is tipped away from the sun. So there is more direct rays hitting the southern hemisphere than there is the northern. And so they would be in winter. Southern hemisphere would be in summer. And so you can see here at the tropics, it's more of a direct angle of light. And then you get more of the scattered light or this lower angle as you get farther and farther towards the poles. So here's the temperate zone. Temperate would be right in here. So most of the US. And then the polar zones, you can see the angles even less. So they get, all right, we had a little freezing problem there. Alrighty, so we can see here, this is the tropics. So between 23.5 degrees north, which is called the Tropic of Cancer, and 23.5 degrees south, which is the Tropic of Capricorn. And so in this area, this is our tropics. The equator falls right in the middle, and they receive the most direct solar radiation. So this is our warmest area of the globe. So it's warmest as far as weather goes. It's warmest ocean-wise because of that solar radiation. And then here we have the temperate climate. So temperate climate is all of the U.S., almost all. A little bit of Alaska is not included in that. But we have all of the U.S. for the most part. And then we also have down here. So you can see this was the tropics. And then between the tropics and the North Pole is a temperate region. And between the tropics and the South Pole is a temperate region. And so temperate is kind of just moderate. So temperate regions are the most affected by the tilt, the Earth's tilt. And so we get to the polar zone. So the polar zones are, of course, above that. So we've got the North Pole and the South Pole. And these areas are 66.5 degrees north or south. So this would be our Arctic and Antarctic circle. And it tends to be very cold because the angle of the sunlight is much less than at the equator. All right, and then if we look at water, water heats up and cools off a lot slower than land does. So if you've been to the lake in the summertime, maybe at the beginning of the summer, and it's 100 degrees outside, but you go to the lake and it's still really cold, that's because it takes a long time. It absorbs a lot of energy, and so it takes a long time to heat up. But then the same is true for the end of the summer. So it's the end of the summer, you go out to the lake, it might be cool temperatures, but the lake is still warm. It still feels like it does during summer. And so that would be because it's holding on to that heat. It takes a long time to heat up, but it also holds on to that heat for a long time. So if you live near a body of water, your temperature is going to be regulated by that water. So Eureka's temperature is pretty moderate year round, and that's or mild. I mean, year round, and that's because of the ocean. Same thing with San Francisco or any of the coastal cities. There's a slight variation between day and night, summer and winter, but they tend to have very similar climate throughout the year. And that's because of the water regulating that temperature. All right, and then the last thing, I believe, nope, almost. So this is called orographic lifting. And so we learn this with cloud formation, and we learn this with weather in general. But there's also something called a leeward and windward side of a mountain. So this is the windward side, and this is the leeward side. And so notice as orographic lifting occurs, it creates clouds and then precipitation. But by the time it gets over the other side, the air is descending, it's dropping. And when it does that, just like high pressure, it warms up and dries out. And so this would be like the Nevada side. So if you think of the Sierra Nevadas, this is the kind of California, Tahoe side. This is the Nevada side. So definitely, and this is true for all mountains. So even like Bali or Shasta or Lassen or any hills around here, there's always a cooler, rainier side, more lush side, and there's always a drier side. And that's because of this orographic lifting. All right, and then our last thing to talk about is the different types of air masses. So air masses affect the climate in that region. So if we look at maritime polar, so this is kind of review, we went over this before, but maritime polar, maritime means wet, moist, it's forming over the ocean, and then it's polar, so that means cold. So this is cool, humid air. And then we've got continental polar, which is cold Arctic air, so really cold, dry air. And so that's coming down, mixing here in the US. And then we've got continental tropical. So this is dry, warm, so dry, hot. And then maritime tropical, which is warm and humid because it forms over the ocean. So anytime it says continental, it's dry. Anytime it says maritime, it's wet. And tropical means warm, polar means cold. So notice what happens in the US. Then we have the jet stream kind of moving across here, right? Because the westerlies are pushing across. So right here we get, our hurricanes coming in and things like that. But here we get a lot of mixing. So you can see there's a lot of mixing going on here. And it's the flat area, the plains that I had talked about. And so the jet stream also comes across and mixes these air masses. And so they often get tornadoes in this area. So this is called Tornado Alley. And that's because of this mixing here of cold and warm air. And this is moist air, this is dry air. So it's a definite difference in air. And then over here, we don't really get that too much. Mainly, we have the ocean kind of regulating that. We have a lot of mountains over here, so we're not going to get a lot of vast movement across a wide area. So we get a lot of lifting and dropping and stuff because of the mountains. So we don't really see tornadoes here. But here we do, and that's because of that mixing there. And these are the types of air masses that affect the U.S. So understand them, and like we did before, just know that maritime means wet. So it's absorbing moisture because of evaporation. So that type is going to be wet anytime this is maritime. And then tropical, of course, you guys should relate tropical to warm weather. And then polar, I would hope that you would relate that to cold. Continental means dry. So anytime you see continental, it's dry. So dry, cold, wet, warm, dry, warm, and so on. Okay. And that is it. So I will see you next time.